So we have question 3. OAN, OMB, APB are straight lines. AN is equal to 2OA. M is midpoint of OB. Vector OA is A. Vector OB is B. Vector AP is K. Vector AP is equal to K of vector AB, where K is a scalar. Give it that MPN is straight line. Find the value of K. So we need to put in the information on the diagram. OA vector is A, and vector AN is double vector OA, so that is 2A. The whole vector ON is 3A. Also, we know vector OB is given as B. Now, given that MPN is a straight line, then MN, if MPN is a straight line, then the full length MN is a multiple of MPN or MP. Whichever way you do it, it will still work, but you need to find out the easier way. So I'm going to compare MN with PN. So which means I must know the vector MN and I must know the vector PN. So I start with vector MN. Vector MN is simply vector MO plus vector ON. And vector MO, you're going against the vector B. And M being halfway of OB means it has to be a negative half B. So I have negative half B plus 3A because ON. Now, I now go back to work out vector BA. Vector BA. The reason for vector BA is this. If I manage to work out vector BA, I will be able to work out vector PN by knowing PA plus AN will give me vector PN. That's why I need to work out vector BA. So vector BA is given by vector BO plus OA. So vector BO is going against the vector B, so it has to be negative B. And that is along that, so that will be a positive A. So negative B plus A. Now, we've been given a clue that AP, vector AP is K vector AB, right? So, given this, it means that the fraction is K. So we are now going to multiply K through the vector BA. This is what we have. So PA will now become negative KB plus KA. So that is the value or the vector for PA. So now I can now work out PN, and PN is P vector PA plus AN, and our vector PA is this, and our AN will be 2A. So this is what I have. Then I just have to simplify. What I've done is that vectors, they have components. So here you realize that the components are B and A. So everything that I'm doing must try to keep it in that components B and A. So what I did was to factor out A so that I could have a component of A and B. So I can see clearly that the B, the coefficient is negative K. Now for the A, the coefficient is K plus 2. Okay. Now we come back to our rule. This is what we got for PN. This is what we got for MN. Now, if we go by what the question says, and that MPN is a straight line, then it means that PN is a multiple of MN. If we happen to know the values, you could just check and see, oh, K is this or K is that. But here we have K on B and we have K on A as well. So what we need to do is that it means that the ratios of their coefficient should be equal for it to really become a straight line. So we are going to compare their coefficients and set up ratio, meaning negative k over half should equal k plus 2 over 3. That's what I mean by equating coefficients, ratio of coefficients. So we set up this, the negative will cancel out. So if you divide k by a half equals k plus 2 over 3, this is what you will have. Cross multiply 3 times k is 3k. Remember, the negatives cancel out. So 3 times k is 3k, and half times k plus 2 is k plus 2 over 2. You can do cross multiply and have 6k equals k plus 2. Then you group the k's by minusing k from both sides. So you're going to have 5k equals 2. Then you divide by 5, and k will be equals to 2 over 5. So this is similar to a question we solved in lesson 5, where we have the outcome to be numbers, so we're able to just spot what is missing. But here we have an expression, therefore you need to learn how to create equation. So k is 2 over 5. Let's look at